this one I want to do fast is if it's a lot of content. If I can make the 5 minutes, got to go fast. Um, I know multicast. Yeah. And it's based on my experience. Okay, way back in the day, we took these giant 32 bits and said this is going to cover the world. We developed these classes, and that was going to be cover all the machines we needed to. That wasn't true. We had this other group of addresses and these classes. It's based on bits. So class A started with a 0, class B started with 10. Class C 110 and Class D 1110. So it's a /4. That's the space. And it's there just so it's really clear this isn't normal traffic. It's the group address. It's not a destination in the way it is with all the class A, B, and C. It, and it's never a source. It's not a thing, it's a group. It's not an individual. It's not a PC. It's not a server. It's not an application. It's a group. Okay. We set aside some ranges. The very first one, and I'm going to use some language which is a little imprecise. We can call it a class C or a /24. It's not in the sense of like subnets, but that block of addresses we set aside, we set the TTL to 1. We don't want it routing. Because if I'm sending OSPF hellos, it makes no sense if I'm not your neighbor, if I have to go through a layer 3 hop. Only if we're on the same layer 3, then we're actually neighbors. So I don't want that packet go anywhere. But there are other things like NTP that I may want blocking my entire campus. So yeah, have this go beyond just my layer 3. And so that particular range, again, it's a 24-bit range that is supposed to be for really critical services. Okay. Now, all this stuff gets registered in IANA, and it's respected by vendors some days. Sometimes it is not. There's a source specific range, and that's there to deal with the problem with rendezvous points. And that's going to be a big topic. That's going to be a lot of little 5-minute chunks. And then there's this one range that we get. It's a /8, so it's big. It's this 239 range. That's where we're supposed to take everything in our private enterprise and put it in that range. Vendors are going to come in, oh, we use blah, blah, blah range. Yeah, it's in a reserve range. No, you're not supposed to. And the challenge is when they free associate, unless you're really good about keeping all that stuff documented, later on you have no idea what this traffic is. And it's not conforming to what the standard is. It's not in this administrative scope range. You just have no idea, and then you're scratching your head trying to figure it out. Now, I show these with CIDR notation, and I'm not talking about them like a subnet. What I'm just saying is, hey, what I can do is I can take a block of addresses, and so as I set up boundaries that I may allow in, like the enterprise range, this regional range, and I may block going back out again my campus range. So that's how I'm looking at it. I'm not looking at it like in any way like a subnet. There's no gateway to this because it's a group address. It's always a destination. Okay. There's two others. These I don't have any personal experience with. This was an idea of being able to do multicast across the internet. One of them based on your BGP ASN and the other based on the prefix you got assigned. The challenge with the prefix one, well, we lop off 8 bits. So if you have smaller than a /24 assigned to you, you get 0. If you have a /24, you only get 1 address you can use. So unless you got a really big assignment that you don't have a lot of addresses to play with, and of course all the fun of trying to do multicast across the internet, all the challenges of that. So yeah, uh, I've not done it. The other thing about going to the IANA registry, which is really useful, is these assignments. So We see 1.60, it says HP. If you click on the name when you're actually in the registry, you can see if you're really kind of not sure what VCALs is, it may be helpful if I click into it and I can see what the domain of Masato Shindo is, or I might also Google it and see what I can come up with. If we're trying to figure out what this is, just because you see it on your network doesn't mean this is actually doing it, but it's certainly a possibility. Um, and so in that case, it can just help me go, okay, is that traffic we actually need to use, or is it just something like the HP printers are turning on by themselves for discovery for other purposes? And we don't we don't really use the HP printers. We're using a different manufacturer, so we don't care. We can block that traffic. So this is also very useful information on the discovery side. Just to really emphasize, always the destination, never a source, ever, ever. We're really talking about /32s because always a single group. Um, Now, an application may need a range of addresses. And as an example, in Formacast, which is Cisco's phone paging, with that one, um, yeah, you dial some digits, phones, pick up, the store will be closing in 5 minutes. Please bring your purchase to the front cash register, right? And I hear it go off and across the store. It's possible that I may need to have more than one of those conversations going. So, like in a healthcare setting, maybe, I've got something in pediatrics and somebody else is doing something over in like ER. And so I give that application a range of addresses to pull from. And they may use them in all kinds of different ways. Uh, One of them, maybe they just, first come, first serve. So, you do one page, and that'll be, that this group of phones is going to tune into this group for your page. Okay. Um, it's not like a subnet. There's no gateway or anything else. Just hey, and I do it that way so I keep track of this belongs to this application, um, and I also make sure that I scope things large enough so that that application can function properly. So it's a conversation with the vendor, or if we have an internal design engineer who's working on the deployment, that we make sure we do this right. But it's always it's always /32. It's always just one thing happening. Okay. Thanks for watching. That's my YouTube channel. Suggest topics in the comments. And these little 5-minute chunks, like them. And that way, as you work your way 5 minutes at a time, you can see, hey, I've already listened to that one. And you can come back if you wanted to kind of soak it in a little more. That's great. I was a teacher, I understand. But um, you know, take this thing one small chunk at a time. Thanks for watching.